So for today, we will be having applications of differential equations as we see here. So now we will be applying the methods that we learned in solving for the solutions of a differential equation, finding the complete solution and the particular solution. And we will be extending these methods in real-world word problems. Okay? And this is our outline for today. Let's start. So the first one is on equations of curves. So before we start, let us recall muna, okay, a very special application of the derivative na siya ay simply the slope of the tangent line to the graph of a curve at an arbitrary point. And it's precisely given by the notation dy over dx. So before, okay, ang ginagawa sa atin is, given a curve y equals f of x, pinapahanap yung dy over dx. Minsan, pinapahanap rin yung particular na slope of a tangent line at some particular point of tangency. Ngayon, we will reverse the process. Okay? Yung unang given sa atin ay yung slope ng curve. Yung equation ng slope ng tangent line at any point of the curve. And then, the goal is to look for the curve. No? What is that curve that has this equation as the slope of its tangent line? Kung dati nagdi-differentiate tayo to get the derivative, ngayon, given the derivative, we will be integrating. Okay, to get the equation of the curve using the method that we learned in solving a differential equation. So let's see how we will do that in this example here. Okay, so we have here example number 1. Here we are to find a function y equals f of x, so a curve, yun ang pinapahanap sa atin, satisfying certain properties. The first one is that we want our curve to pass through or contain the point 0, 4/3, that's first. And the second condition that we wanted to satisfy is that its derivative is equal to this expression right here. Hinihingi sa atin y equals f of x satisfying two things, no? We want na una, it satisfies na pinapass through niya yung point 0, 4/3. That is, kapag ang x natin ay 0, we want that our function satisfies na ang y niya ay 4/3. That's one. And the second one is, we want that its derivative is this. Kapag derivative, ang ating notation for that is precisely dy over dx. So, gusto natin derivative ay equal dun sa expression. So, that's x squared root of 1 minus x squared. And that's it precisely. Here sa ating second condition, nakagawa tayo ng isang differential equation. So, gagamitan lang natin yung methods natin in solving a differential equation to get yung desired natin na y. But here, we subject it to certain conditions. Ito siya. Okay? So once you've found the complete solution of your differential equation, i-input natin tong additional conditions natin in order to find a particular solution. And from there, mahahanap na natin yung particular curve satisfying the desired conditions. So game, let's do that. So as I said, pag sinabing derivative of the function is this expression, rewriting it mathematically, ganito lamang siya. This is a dE. And mula sa ating previous lecture, to solve for this dE, we first separate this dE, and then afterwards, integrate both sides. And so we have this. Ginawa na yung first two steps agad. Alright? Now, we just integrate each side of our equation here. Yung dy at yung dx, it reminds you, by the way, to which variable nyo i-integrate yung kada side. Okay? So itong nasa left natin, dahil naka-dy, we will be integrating with respect to y. So ang integral ng dy therefore, simple lamang ay y. So y itong nasa left natin. Meanwhile, itong nasa right natin, i-integrate natin siya with respect to x this time. Okay, so sana by now, medyo natural na sa atin yung pagpili ng efficient choice for u. If you try using u equals 1 minus x squared, okay, then what will be your du therefore? It becomes negative 2x dx. Okay? And how do you know if this is a good choice for you? You should see it or something like it dun sa ating integrand. And in fact, you can see it here, okay? Because you have an x here and a dx right here. Okay? You just have a negative 2 dun sa inyong du, but because it's just a negative 2, it is just a constant. We can just play with it and transfer it dun sa other side natin. So let's do that. Okay? In order for it to specifically look like x dx, then lipat natin yung ating negative 2. It becomes du over negative 2 equal to x dx. And so therefore, if we will be rewriting our right side all in terms of u, ma-absorb na lang ng du over negative 2 si x dx. And we have this. This one became u raised to 1/2, again because we chose 1 minus x squared to be u. And ni-raise lang siya sa 1/2 para u raised to n at mabilis ma-integrate. The x dx, as I said, ay na-absorb lamang yan ng du over negative 2. Ang du over negative 2 is just negative 1/2 times du. At ang negative 1/2 ay lalabas sa integral mula sa properties ng integral. Okay, so we can thus integrate and we get this. Your left side again became y. Your right side became like this because ang integral ng u raised to 1/2 ay u raised to 1/2 plus 1 over 1/2 plus 1. And that's precisely u raised to 3/2 over 3/2 or that's times 2/3. Meron kang negative 1/2 here, kaya naging negative 1/3 siya. And then don't forget to attach your plus c because this is an indefinite integral. And if you also recall from our previous lecture, we only place just one constant of integration plus c. Hindi na natin kailangan lagyan yung nandito sa left. Ayun. And then bringing back all your expressions in terms of x, we have this one here. So na-solve na natin yung initial na DE natin at nakuha ang complete solution, but we want our curve to pass through 0/4 as well. Subjecting our complete solution here to 0/4, this just means that kung ang x ng ating function ay 0, then dapat ang y niya ay 4/3. So we just substitute both values actually. What we get is this one, at kayang ma-solve na therefore si c, makukuha ang particular value ni c. Pag nakuha na, this is what we get, and we substitute it back to our complete solution so that what we get is a particular solution already, and this is the precise function that we want here. Okay, next tayo. Still on equations of curves, so basahin ko ang ating problem. At any point xy on a particular curve, the rate of change of the slope of the tangent line is equal to 6x minus 6. Find the equation of the curve if the tangent line has slope 9 at the point -1, -4. Okay. So, yung pinapahanap sa atin ay isang curve ulit. So, actually still y equals f of x. And then, ano yung mga conditions na dapat sinasatisfy ng ating curve? Una, okay, dapat ang rate of change of the slope of the tangent line is 6x minus 6. Wow. So, i-analyze natin itong phrase na ito. Ano bang sinasabi nito? Well, yung slope of the tangent line, alam natin na yan ay precisely the derivative, no? So, dy over dx siya, or I'll write it here as y prime. Okay? Pareho lang naman yan. Pero here, what we want, in fact, is the rate of change of that. Okay? Pag sinabi rate of change, it gives you the signal to differentiate something, actually. Dito, rate of change of the slope. So dito, i-differentiate natin, actually, yung y prime with respect to x. Take note that this notation is also equal to d squared y over dx squared. Pero recall dun sa previous lesson natin, pag mga order 2 na differential equations, we prefer the notation here sa taas. Okay? Para mas orderly yung ating DE. So yun yung gamitin natin. We want that is equal to 6x minus 6. And in fact, this one is already our DE. Yan na yung isosolve natin. Yun nga lang, na-subject ang ating equation to initial conditions. So, particular curve, particular solution ang hahanapin natin dito actually. Ano yung mga conditions na given? Sabi niya, we want the equation of the curve such that the tangent line has slope 9. And again, ang slope ng tangent line ay precisely dy over dx. Derivative lamang siya, y prime lamang siya. And gusto natin, ang value niya ay 9. Yan ang slope ng tangent line. We want that this occurs, take note, at the point -1, -4. Ayun. So, using all those conditions, let us now solve. We have here dy prime over dx equals 6x minus 6. And then, balikan lang natin yung methods natin sa pag-solve ng isang DE. In this case, a DE of order 2. So, therefore, mag-2 rounds tayo ng ating separating and integrating. No? So, doing the first round, we have this. Sineparate niya ang ating DE at in-integrate na rin both sides. Here, for the left side, we are integrating with respect to the dummy variable y prime. So, ganun lang rin, ang integral ng dy prime is just y prime. Okay? Meanwhile, yung ating left side, this is just a polynomial, medyo madaling i-integrate, no need for u sub. Ito na siya agad. Okay? Y prime equals 3x squared minus 6x plus c sub 1. Dito, c sub 1 ang name ng ating constant because this is a DE of order 2. And recall, the order of your DE, nagko-correspond doon yung number of constants that you expect. So dito, we expect 2. Kaya pinangalanan muna siya as c sub 1. Now, before doing the second round of separation and integration, okay, kaya na natin in fact mahanap yung actual value ng c sub 1 mula dun sa initial conditions na sinobject tayo with. Okay, here we required that the slope of the tangent line is 9 when we are at the point -1, -4. So let us substitute that. So here, because y prime or dy over dx is 9 at -1, -4, or at x equals -1, sa ating nakuhang equation, wala namang y involved, only a dy over dx or a y prime and an x. No? So hindi pa natin mapansinin yung -4 for now. Substituting 9 na y prime and -1 na x, we have this one here. And we just solve for c sub 1. Solving for c sub 1, in fact, wow, 0 lang pala siya. Okay, so therefore, pwede nang i-input yung ating c1 na hanap na yung actual value for our c sub 1. So therefore, this is what we have. Sinubstitute na yung c sub 1 na 0 at pinalitan na rin yung ating y prime to become dy over dx. We just want it this way para kayang ma-separate yung ating DE and go back dun sa methods natin sa pag-solve ng DE. Okay, so now doing the second round of separation and integration, okay, we have this one. We integrate the dy here, now with respect to y na mismo, and then we integrate this one, yung expression polynomial pa rin naman, so carry integrate without u sub. So integrating, we have this. Y equals x cubed minus 3x squared plus c sub 2 this time. C sub 2 kasi ginamit na yung c sub 1 kanina. And really, indeed, we have 2 constants of integration as expected naman. So we just need to solve for our c sub 2 here. Saan natin kukunin si c sub 2? Dito na papasok yung -4 kasi naka-y na siya. No? And gagamitan na rin natin also yung ating x na -1. So substituting that, we have this one. Pinalitan na yung y to be -4 at pinalitan na rin yung mga x's to be -1. Solving for C2, what we get is 0 lang din pala. Wow, okay. So parehong constants natin turned out to be 0. Okay lang naman yon. So inputting all those C's, we have as our final equation for the curve to be this one. Y equals x cubed minus 3x squared mula lamang dito. Okay, so now let's go to the second type of application of DE that we will learn today. And that is rectilinear motion. No? Something we've seen na already before, specifically dun sa topic ng applications ng derivatives. So recall natin ulit kung ano yung mga concepts doon. If we have a particle moving along a straight line, it can be vertical, no, pwedeng up-down, or pwedeng horizontal, left-right. And we denote S of t to be the position of the particle at time t. Then, ito ang ating relationships with our velocity function v of t and our acceleration function a of t. That is, yung first derivative ng ating position function s prime of t is given by v of t. And the first derivative of our v of t is given by a of t. So before, given ang ating S, kayang makuha si V by just differentiating it once. Kaya ring makuha ang ating A mula sa pag-differentiate ng ating V. Ngayon, i-reverse lang natin basically ang ating process kasi integration na tayo ngayon. Okay? We can integrate both sides of the equations here. And so we have corresponding integrals. No? Kung ang first derivative ng S ay equal kay V, then yung integral ng v of t dt is s of t lamang. And at the same time, wala lang sa ating second equation, yung equivalent integral niyan is yung integral ng a of t dt is precisely our v of t. So, ni-reverse lang talaga natin ang ating mga processes. Sa game, let's apply these formulas in examples. So, here we have our example 3. I'll read it first, maybe. A stone is thrown upward from the ground with an initial velocity of 128 feet per second. If the only force acting is attributed to acceleration due to gravity, negative 32 feet per second squared, we are to determine, letter A, how high the stone will reach. Letter B, how long it will take the stone to strike the ground. And letter C, the speed with which the stone strikes the ground. Okay, so this is a problem on rectilinear motion. Pag meron kayong ganong problems, maybe try sketching yung situation nyo sa problem. Dito meron tayong stone, okay, na thrown upward from the ground. Very important na i-note itong from the ground siya. Because in fact, this gives you a condition already sa problem na ito yung reference point nung particle mo. So, let's note that here. So, let's draw that. Meron ka ditong reference point na mula sa ground, okay, binabato ang stone natin. See, that's our stone. And it's being thrown upward. And then, of course, it being thrown upward, babalik at babalik siya pababa sa ground natin. So, may time na mapupunta na dito yung stone at bababa siya muli sa ating ground. So, yun yung situation. Let's see kung ano yung mga other conditions given sa problem. Dito, sabi, ang initial na velocity ng ating stone is 128 feet per second. I'll use our usual notation for the velocity function, v. Okay, and initially daw 128, so at time t equals 0, in fact, ang kanyang initial velocity ay 128 feet per second. That's one condition na sinasatisfy ng ating stone. Sinabi rin dito na the only force acting on our stone, okay, is attributed to acceleration due to gravity. So ito siya. And binigay rin yung constant na value ng acceleration due to gravity natin, which is negative 32 feet per second squared. So again, using the usual notation for our acceleration, a of t natin is negative 32 feet per second squared. No? Constant lamang siya so that it's always negative 32 whatever our time t is. Meron pa in fact na isa pang initial condition na naka-layout dito sa ating problem. Baka hindi siya masyadong nakikita, pero banggitin ko na rin siya. In fact, the idea that your stone is being thrown from the ground, yung initial position ng ating stone relative to the ground is in fact 0. So, we have another initial condition satisfied here na ang S of 0 natin, initial position of our stone, is in fact 0 feet relative to the ground. Okay, so ito na yung mga conditions satisfied ng problem. Kayang-kaya na natin siyang ma-solve. Let us first look at letter A. So dito, we are to determine how high the stone will reach. In other words, hinahanap lang natin dito yung maximum height ng ating stone. If you recall from our previous lesson lang rin sa rectilinear motion, the maximum height of the stone is achieved precisely at the time t when your velocity is equal to 0. But here we don't know yet what v of t is. And in fact, we also don't know what s of t is. Pero okay lang, kaya rin natin yung makuha actually mula lang dito sa ating a of t. So, i-integrate natin twice ang ating a of t, once to get v of t, and another time to get s of t. Okay, so doing that, hanapin muna natin si v of t at si s of t mula lamang dun sa ating a of t. So, we integrate our a of t, dt here, and get v of t. Ang ating a of t is given in the problem to be the constant negative 32. Integrating, what we get is negative 32 plus c sub 1. C sub 1 ang ni-write niya dito na constant of integration because just like in the previous example, twice ka kasi mag-i-integrate dito eh. So it's similar to yung method natin kapag meron tayong DE of order 2 na you will be expecting 2 constants of integration here. Okay? So actually ito na yung pinaka V of t natin, but just like yung previous example natin, kailangan natin mahanap yung particular value ng ating C sub 1. Where will we get that? From one of our initial conditions. And precisely dun sa initial condition na ang initial velocity ay 128 feet per second. That is, yung value ng ating v ay 128 at time t equals 0. So substituting these values, what we get is this. Pinalitan na yung ating v to become 128. Pinalitan na rin yung t to become 0. Hahanapin na lang si c sub 1. Finding c sub 1, we have this. And so, we already get our function for the velocity. Okay? Negative 32t plus 128. Next tayo, okay na ang ating v. Let us just get our s of t, yung ating position function. So, we will be needing to integrate this once more. No? So, integrating our v of t, we have here integral ng v of t dt. What you get is s of t, yung position function mo na. Okay? So, input lang natin yung ating v of t. It is this one, negative 32t plus 128. And we integrate this once more. So, ito ang makukuha natin. Okay? Negative 16t squared plus 128t plus c sub 2. c sub 2 this time because we used c sub 1 again earlier na. Okay? So, we just need to get this particular value for c sub 2. Saan naman natin kukunin yung c sub 2 na yan? You just sift through your conditions na concerning s. No? Dito, dun siya dun sa naka-throw from the ground kasi yung stone. Okay, so yung initial condition corresponding to that is s of 0 equals 0. So, ang ating s position ay 0 when the time is equal to 0. Okay? So, substituting these values, 0 lang actually lahat. So, therefore, it will turn out na ang c sub 2 natin ay 0 lang pala. So, therefore, ito na yung s of t natin. No? This is our position function already. So, we found v and we found s already. Kaya na nating ma-attack yung mga hinihingi dito. So, una, how high the stone will reach ang gusto sa atin. Again, inihingi lang nito ang maximum height. And the maximum height is achieved when our v of t is equal to 0, recall? So, equate lang natin sa 0 ang ating nakuhang velocity function from the previous slide. So doing that, solving for t, what you get is this. So ang ibig sabihin nito, yung stone being thrown upward, na-achieve niya yung max height. So tumigil siya dun sa air at t equals 4. And from t equals 4 onwards, doon na siya bumaksak pabalik sa ground. So, na-achieve si max height at 4 seconds. But this is not what we want yet, no? Ang gusto natin ay yung mismong height, how high the stone will reach. So, we substitute this t equals 4 dun sa ating position function. So here, what we have is s of 4. And looking for s of 4, after arithmetic lamang, ay 256 na siya. So, 256, therefore, yung maximum height na ma-achieve ng ating stone. So, yun yung sa first one. Okay. Next. Yung next na tinanong is how long it will take the stone to strike the ground. Okay? Kasi again, si stone ay binato upwards. Binato siya upwards, na-achieve si max height, babalik siya sa ground. So, ang tanong, gaano katagal yung kanyang motion? Well, dito, gusto natin the stone ay magsastrike sa ating ground, and it's striking the ground means that its position relative to the ground is 0. No? So, dito, hinahanap natin yung particular time t such that ang s of t natin ay equal sa 0. So, equate lang natin sa 0 ang ating position function. And we have this. So, ito yung position function na nakuha natin sa previous slide. So, looking for our t here, factorable itong ating left side, no? So, we can factor it out as follows. And we can get our t. Here you have two values for t. T equals 0 and t equals 8. Pag in-analyze natin yung t equals 0, ang ibig sabihin nun, throw lang natin yung ating stone mismong from the ground initially. No? But that's not what we want here. Ang gusto natin is yung second time na masa-strike siya sa ground. So therefore, yung t equals 8 lang ang kukunin natin dito. And 8 seconds yung ititake ng ating stone to strike the ground. Finally, yung last na pinapahanap sa atin is the speed with which the stone strikes the ground. So basically, the speed of the stone at impact dun sa second time na pagbaksak niya sa ground. Nakuha na natin kasi kanina yung particular time that it will take for the stone to strike the ground, which was 8 seconds kanina. Kailangan lang natin yung speed at that particular time t equals 8. And if you recall, itong speed, okay, ay actually very related sa ating velocity because the speed is just the absolute value of our velocity. So we only consider, in fact, the magnitude of the velocity. We don't consider the direction. Kaya natin kinukuha yung absolute value. So yes, substitute lang natin yung t equals 8 sa ating velocity. Again, because yung stone natin ay nag-strike ng ground after 8 seconds. This is what we get as our velocity, okay, negative 128. But what we want is the speed. So we just get the absolute value of our velocity. So doing that, we just get simply 128 feet per second. So yan yung speed ng ating stone at impact to the ground. Okay, so let's go to our example 4, last example for our rectilinear motion. I'll read first our problem here. No? From the top edge of a building, 112 feet high, a stone is thrown upward with an initial velocity of 96 feet per second. Assuming the only force acting on the stone is due to gravity, find A, its distance above the ground after t seconds, and B, the time it will take for the stone to strike the ground. Okay, so just like what we did dun sa previous example, maybe let us draw, okay, our situation here. So again, may stone na naman na binabato. Okay? Pero dito, different na siya because we are throwing the stone actually on top of a building. So I'll draw my building. Alright? Yan ang aking building and this is my stone. Sino-throw yung ating stone actually pataas tapos parabolic siya na pababa. Okay? Kasi after some time, it will be reaching the ground, in fact. Ang ating building ay of a height na 112 feet. Now, it's important to establish what your reference point is. Because if you define different reference points, you will also be getting different position functions. For example, if I chose as my reference point the ground, the stone being thrown from the top of the building means that its initial position is in fact 112 feet from the ground. Meanwhile, if, for example, I chose the top of the building to be my reference point, okay, then yung initial na position ng aking stone relative to the top of the building is in fact 0. And so therefore, pag ito-throw ko na yung stone and then it reaches the ground after some point, I expect position here of my stone na actually negative kasi nasa baba na siya dun sa horizontal ng ating top edge ng building. So, it's very important to establish kung ano yung inyong reference point. No need to write naman, no? Parang alam niyo lang dapat in yourselves kung ano yung gusto ninyo. For my illustration here, maybe I'll use na lang the ground as my reference point just so my positions are all non-negative. But it's up to you kung saan kayo comfy. No? So ako, ground ang gagamitin ko. So therefore, isa sa mga initial conditions ay yung S of 0 ay 112 feet. Okay, let's see pa kung ano yung mga initial conditions natin. Dito, the stone is thrown upward with an initial velocity of 96. So very similar lang din sa ating previous na problem. Ang V of 0 natin ay 96 feet per second. Okay? Now, next, meron pa. Assuming the only force acting on the stone is due to gravity. So yon actually, sinasabi noon na yung nag-a-act sa ating stone ay acceleration due to gravity, in fact, and that's the only thing that acts on it. Okay? So, dito ulit papasok ang ating A of t, yung acceleration due to gravity natin. Na dito, in fact, walang binigay na exact na value ng ating acceleration. Whenever you encounter problems like this, it is safe to assume. Kasi yung standard na constant acceleration natin dito sa Earth is given by, in fact, negative 32 feet per second squared. So, dito sa problem na to, pwede na natin i-assume na negative 32 feet per second squared siya. Okay? So, ganun kapag meron kayong problems no, na hindi naka-give explicitly yung acceleration, pwede nyong i-assume based on the units involved sa problem nyo. Dito naka-feet, so yung standard na acceleration due to gravity natin ay negative 32. Kapag, for example, naka-meters, okay, yung standard na acceleration due to gravity natin ay negative 9.8 meters per second squared. But here, we will be using negative 32. Okay, so we've laid out, in fact, all our conditions. Okay, let us now determine muna, letter A, okay, the distance of the stone above the ground after t seconds. Okay, so dito actually, hinihingi lang sa atin yung position function, in fact. So, yun, hahanapin lang natin ang ating S of t na makukuha natin mula kay A of t lamang. So, let's do that. Let us integrate our A of t to get S. So, we find our S of t here na kaya nating makuha mula sa acceleration by integrating twice. So, syempre, dadaan muna tayo sa ating velocity. So, integrating our negative 32, we have this, negative 32t plus c sub 1. And similar lang rin sa ating previous example, we have to look for the value of c sub 1. How do we get the value of that? We subject it dun sa condition related kay v. Yung fact na ang initial velocity ng stone ay 96. So, yung v natin ay 96 at the time t equals 0. So, substituting v na 96 and t na 0, we get this, and we get this c sub 1. So, nakuha na natin ang ating velocity function precisely, this one. But this is not what we want yet. What we want is the position function, in fact, no? So, we have to look for s of t. Looking for s of t, we integrate once more our v. Lagay lang natin kung ano yung nakuha nating v. And integrating, this is what we get. Okay, confirm nyo na lang yung mga nakukuhang values here, alright? And then you have a plus C2 here. C2 na siya kasi C1 siya kanina. Looking for the value of C2, i-input lang natin yung condition na concerning si S. And actually, it was this one, no? Because the stone was thrown from the top of the building with a height of 112. Yung S of 0 natin kanina was 112. Yun yung condition natin dito. At time t equals 0, yung position ng ating stone ay 112. So, substituting your S and your T, zeros lang tong T natin, yung S natin 112. What you get for C sub 2 is 112 pa din. Okay? So 112 ang ating C sub 2. And so inputting that, we have this as our S of T. Okay, so yung letter A done. We just have to answer letter B here. Dito, tinatanong the time it will take for the stone to strike the ground. Similar lang dun sa previous example natin. No? If you want the stone to strike the ground, then that just means this is the time when the stone has a position na 0 relative to the ground. So, S of T equals 0 ang gagamitin natin dito. Okay? So, yes, we find that T such that ang S natin ay 0. Equate lang natin ang ating S of T kay 0 and looking for our T. This is factorable. Paki-confirm and verify na lang ang mga factors dito. This is what we got when we factored it out. So therefore, the T that we get is 7 and negative 1. But we don't get the negative na value for T because our T denotes time. So we only take positive values for our T here. Okay? So therefore, it will take the stone 7 seconds to strike the ground. That's it. Okay, so we are down to the last type of application ng differential equations natin. And in fact, yun lamang ay ang ating marginals, no? So mga money matters, okay? Nakita na natin din ito before dun sa applications ng mga derivatives. So recall lang natin sila once more ulit para sa lesson na ito. So if C of X is our cost function here, R of X is the revenue function, and P of X is the profit function, where yung mga X natin dito, yung mga independent variables natin, denote the number of units produced. Okay? Then, yung relationship ng tatlong functions na ito is given by this equation. Ang ating profit is just equal to the revenue minus the cost. Na tama naman, no? In Filipino terms, tinuro rin sa atin to dati, yung nabebenta natin minus yung ginagastos natin ay equal sa kinikita natin. Yun lamang siya, no? So ito yung relationship nilang tatlo, and we were also introduced sa previous unit nung mga marginal functions na ito, no? And they are just basically the first derivative of our cost, revenue, and profit functions with respect to X. No? So marginal cost, marginal revenue, and marginal profit ang tawag natin sa kanila. And yung interpretation natin dito before, touch ko lang quickly, ito yung nag-a-approximate nung cost, revenue, and profit if you produce one additional unit. At the same time, in fact, ginamit rin natin to dun sa topic ng optimization, kung naalala pa. Parang business-minded people tayo. Nag-maximize tayo ng profit, nag-minimize ng cost. So, in fact, ito yung mga ginamit natin doon. But this time, gagamitin natin yung mga concepts na ito in methods involving differential equations. So, kung dati nagdi-differentiate, halos same lang dun sa mga previous applications natin, tayo ay mag-i-integrate this time. So, yes, mula dun sa marginal functions natin, so mula sa mga derivatives nila with respect to X, hahanapin natin yung actual total cost or revenue or profit functions nila. Na kayang-kaya, gagamitin lang really natin yung mga methods natin sa pag-solve ng isang DE. Okay, so let's go to our last two examples for this lecture. I'll read my example 5. The marginal revenue for selling X items is given by dr over dx equals 4x plus 3x squared. If the revenue received from the sale of 10 items is 1,500 pesos, find the total revenue R of X. So medyo straightforward naman actually ang ating problem. Binigay sa atin ang ating marginal revenue for any arbitrary X number of items produced. Okay, and pinapahanap si total revenue. Kayang-kaya. This is just basically solving a DE, no? Binigay na actually in fact yung ating DE dito straight away. Okay? Na-subject nga lang siya sa mga initial conditions na dapat yung revenue natin, yung income natin ay 1,500 pesos whenever we produce exactly 10 number of items. So, isa-subject lang natin si DE natin dito with that. We get a particular solution to our DE, and that's precisely the revenue function that we want. Okay, so let's do that. Solving for our DE na given agad dito. Okay, so sineparate na niya ang ating DE just coming from yung step 1 natin sa method ng solving for DEs. And then, we integrate both sides. And then, yung ating left side, integral lamang ng D capital R. Okay, capital R being treated as a dummy variable lang. So, that left side will just be simply R. Yung ating right side, we are integrating here with respect to X. Kayang-kaya, polynomial naman lamang. So, ayan siya. And then, of course, don't forget your plus C. Plus C here denotes a constant of integration. Now, just like the previous examples, we have to find the actual value. Kasi, sinobject yung ating revenue function that we want here to a condition. No? So, dapat particular na revenue function yung makukuha natin dito. And we just subject it na yung ating revenue ay dapat 1,500 pesos kung yung sinesell natin na item sa item. So, we substitute R equals 1,500 and our X equals 10 here into our complete solution for the R in order to get the constant of integration C. And just via arithmetic, this is what we get. No? 300 yung particular na C na kailangan natin. And so, substituting your constant of integration, what you have is this one. So this is the specific revenue function satisfying this marginal revenue function. And at the same time, nakukuha natin na 1,500 ang revenue kapag 10 items yung binibenta natin. Next tayo, one last example for this lecture. So I'll read it again. The marginal cost for producing X items is given by dC over dx equals 0.05 plus 5,000 over x squared. Find the cost of producing 5,000 units given that C is equal to 5,500 pesos when X is equal to 1,000. Okay, so actually, in fact, it's very similar to yung ating previous example. Doon nga lang revenue yung in-involve tayo with doon. Dito, cost naman. So, yung gastos naman ang involved tayo here. But the process is, in fact, just the same, no? Given na sa atin ang ating marginal cost function here. So, we just need to solve for this DE in order to get the complete cost function. Okay? But what we want is a particular cost function, in fact, na makukuha natin just by subjecting the complete cost function dito sa ating condition. Na dapat daw, pag nag-produce tayo ng 1,000 units of our item, we will be getting a cost or a gastos of 5,500 pesos. But in fact, here pala ang pinapahanap sa atin ay hindi yung arbitrary total cost function for any X. What you want is the actual cost in producing 5,000 units. So, madadagdagan lang ng isang additional mini-step ang ating problem. Isa-substitute lang natin yung X equals 5,000 dun sa makukuha natin na cost function. And yun yung cost na desired natin dito. Alright, so doing all that, okay, let us solve first our DE here. Sineparate na ang ating DE dito. Okay, that's step 1 of solving DE. And then, in-integrate na ang both sides ng ating equation. This one here, yung 5,000 over x squared, ginawa siyang 5,000 times x raised to negative 2 para straight dun sa x to the n natin na form at madaling ma-integrate. So, integrating this, here, by the way, we are integrating with respect to the capital C dummy variable. So, ganun lamang rin, no? Magiging C lang din yung ating left side. Yes. And so, integrating naman your right side, you have this one. Okay? Na dito, ang ginamit na lang na variable ay plus k kasi ginamit na yung ating C na variable here for your cost. So, para hindi siya pare-pareho, okay, ginawa na lang na k. So, ito yung complete cost function natin, in fact. But then what you want is a particular cost function satisfying this condition. So, substitute lang natin itong mga values na ito. So, we substitute C equals 5,500 and X equals 1,000 into this one. And binigay na niya agad yung sagot. In fact, yung K natin ay magiging 5,455. Paki-verify na lang, right, na ito indeed yung constant. So, makukuha na natin, in fact, yung ating total cost function, where this cost function satisfies na ang ating cost o ang ating gastos ay 5,500 kung 1,000 yung sinesell natin na items. But dito, ang gusto natin is the particular actual cost in producing 5,000 units. So, to get that, you just substitute x equals 5,000 here sa nakuha natin na total cost function. So, doing that, okay, substitute lang natin si 5,000 kay C. And after some arithmetic, this is what you get. Confirm nyo na lang ito. 5,704 pesos. So, yun yung gastos natin, okay, in producing exactly 5,000 units, subject to na ito yung kanyang marginal cost function and these conditions as well. Okay, so we're done. In fact, yun na yung ating applications for DEs. Ito na lang yung mga exercises as enrichment na lang sa inyo. Kayang-kaya nyo yan. Alright, so that's it for today and for my lecture videos actually. So thank you for watching and I will see you again when I see you. Bye!